हरि करना।
Welcome to the fourth part of module 1, that is welcome to the DevOps universe. So here we are going to discuss about various stages in DevOps. We'll look into the continuous flow of the DevOps. So here just look into the picture that is present in your screen. So on top shelf, that's a red shelf where all our processes, there we'll find a process flow, and at the middle shelf we will have an artifact registry. It's like a server where we will store our artifacts, or where we'll push our artifacts. And then the bottom shelf where our testers and system admins are going to work, and then majorly the feedback. And just look down here at this part, at the most bottom part of your screen. Here we have a convention for a conventional representation of various symbols, and so blue is for the push, and then red is for the pull, and manual step for integration is yellow, and manual step for delivery is green, and manual step for deployment here is dark blue, and manual feedback is dark red. So now let's begin with development development of the same project, that health issues app. Now to set up all code, first let us our system admin will set up a server for storing the code and controlling the version of it. So that server we call it as a code repository and version control system. Okay, once the server is set up, now it is time for developers to develop the code and push it into the server. Let's see how they do. So we have the developer one, and the developer one has written some modules of the health issues app. Now he has pushed that code into the code repository and version control system. Then we have developer 2. Developer 2 has to pull the code from the code repository and version control system. So he's pulling the code. Once pulling is done, he has developed some part of code. He has integrated that part of code into the existing code, and then he has pushed the complete part of code back to the code repository and version control system. This is how every developer every developer is going to have the complete piece of code of that health issues app. So now developer 1 also is going to pull the changes that are done by the developer 2. So almost we have completed certain modules of health issues app. So development process is done for now. So now we will move on to the another stage. So before we are moving on to the another stage, system admin, he has to set up a server. He has to provision one server, and inside that server we have to configure with certain tools. Nexus, for example, artifact registry, we will use Nexus. So he has to install that Nexus, and he has to set up that server. We call that server as a artifact registry server. So we have set up that server. Then we will move on to the next step. So this is an integration step. It is after development, it is an integration process. In integration process, we will use Maven or some other kind of tool. Basically here what we do is, we will do some unit tests of the source code, and then once source code is tested with unit test, and if it passes the gates, then it can be moved to the building stage. We will build basically we use Maven tool, and Maven tool will build this. For that again we can use a server, build server. we will have a build server, and in the build server we will install maven tool, and then after that we'll use mvn install command to build the artifact. So once that command has been executed, what you get is in a package. That package or artifact or an archive in .or format, if it is a Java exam, if it is a Java application. Anyway, Healthicious is a Java application, so that's the reason we are going with the maven tool, and our package is ready. Now it's time to put this, publish this, push this package into the artifact registry. So now we are pushing this package back into the artifact registry. So now you have a safe place to store your packages. That is our artifact registry. So your integration part of DevOps is done. Now it is time for delivery. So, but before you deliver it, you need to do some tests. You need to do user acceptance test in various environments. So that is the reason. The next thing what we are going to do is, our system admin is going to set up a test environment. Test environment is nothing but he will provision a server. Once the server provision is done, he will install all the tools that are required. Maybe I want to use SonarQube or some other tool, so he will install that tool inside that, and with that we have built a test environment. Once test environment is ready, now our package artifact registry, the package that we have built, the archive that we have built using maven, that will be pushed, or that will be pulled by the testing environment to do the tests. And in addition, at the same time, you can also do the user acceptance test. For that, system admin will set up a one more server, and he will install the required tools, and then that's called configuration. That's what we call it as a configuring the server. Once configuration is done, we will have a quality assurance personnel. He will do user acceptance test on that application that has been packaged, and then he will give that feedback back to the developer if there are any changes to be required. So you will have a quality assurance 2 or 3 personnel who will be working on that. Whatever observations they have made, all observations will be put into the developer 1 and developer 2, and then those guys will do the required changes to make sure a proper functionality of our application health issues app. So now we will move back into the test environment again. So in test environment, we will write some ready to ship tests, such as dev tests, regression tests, performance tests, compatibility test. Dev test is nothing but so you add some comments or a few more pieces of line to the code, and you build it again, and you check it whether it is working properly or not. This is a common test done by the DevOps guys. And we'll check the compatibility, performance, and the regression test. Compatibility, whether it fits with that certain environment or not, and performance, at what speed it's working, and everything. These kind of tests we will do. We'll write the cases and we will test it one by one in test environment. Once all tests are done, if that package, if that application, if that archive successfully passes through all tests, then we will promote it back to the artifact registry, saying that this has passed all the tests, this is healthy, this can be useful. So now from here we will move on to the staging environment. Again, staging environment will set by the will provision and configured by the system admins, and then we will pull this package archive into the staging environment from the artifact registry server. But now you might get, what is testing environment, what is staging environment, why we are doing all those things. So just within 2 or 3 minutes, I'm going to explain the difference between the testing environment and then staging environment. Before that, first we will look into the what is testing environment. A testing environment involves creating a space that lets you to perform test executions of your component parts. Note this point. Keep in your mind, component parts. Every application will have a components. Whether it is front end or back end, it will have a components. If you take the front end, the client facing one, you will have a header, you will have a footer, you will have a carousel, you will have a gallery, you will have a login. So all those are components of the application. Now in testing, what we do is, a testing environment involves creating a space that lets you to perform test executions of your component parts, individual component, not together. So the test environment includes both the software and then hardware you are running it on. So your testing environment is therefore very specific and not one size fits all. It varies. If it is Python app, it should be a different configuration. If it is Java app, it should be a different configuration. If it is Golang app, it should be a different configuration. If it is R app, it should be a different configuration. So that's how your testing environment works. Now, what is a staging environment? You have seen what is testing environment, and now the staging environment is, it is set up that replicates your production environment. That's it. That's your staging environment. So in short, it is an identical replica of your product. You should not be able to find any differences between your staging environment and your final product. But unlike your final product, it's not for the public domain. It is only for the do some user acceptance test in staging area, but it should replicate exactly as a production environment. Now let's see a few major differences between staging environment and then testing environment. Now if you see, a staging environment duplicates the production environment to test the product, whereas test environment helps to test a particular part of the product. Again, I'm repeating it like a broken tape recorder, to test a particular part of the product. That's what the test environment do. And whereas staging environment should be able to replicate all the requirements and correct configurations of the production environment, whereas test environment requires a different configuration and data setups. Thus it has no such thing as one size fits all setup. Now, and the staging environment is setting to examine the complete product together, whereas the test environment is an environment to test individual components. In a staging environment, the complete product is tested under the real conditions, and while in a test environment, the code dictates the setup of the environment. So this is the major differences between the test and then stage environment. I hope you got the point. So let's move ahead. So now we are still in delivery. We have finished with development integration. We are in delivery stage. So now during the staging environment, again we'll write some tests that should be done, and then once the package or archive passes through all the tests that are written in staging environment, then it will be put back to the artifact registry. We say this is healthy and it is gonna work in production. So the trial run is done. Now it is time to put into the production. So what's left next is to create a production server. The system admin provisions and configures the production server. Once that is done, our application will be unpacked or untarred, and that unpacked application will be put into the production server. Hence, this can be used by the external world. So a production server is nothing but exposing our application, our healthious application into the to the external world. So with this, we have finished with development, integration, delivery, and deployment. But what we have done here, everything we have done it as a manual step. No automation is involved here. Whatever we have done, everything is absolutely manual. Anyway, don't worry. Coming ahead in our courses, in our next modules, we are going to do each and every act from developing, then to pushing into the GitHub repository, then building, then doing unit tests, then building archive or package, then setting up the test environment, then pushing it into the test environment, and then user acceptance, then writing the tests, and then creating a quality gates, and then testing it. Once it passes the quality gate, then we'll publish it into the artifact repository. Then from there we'll set up the staging environment. Then we will move on to the we will import that whole package, and then we will untar that package, and we'll put it into the server using a service, and then finally we will expose it to the external world using URL, using a specific domain. All those things we are going to do in this course. So that's why don't skip in between, just continue with me. You are going to get a huge, just for free of cost. I don't want anything from you other than just focusing on the course content. That's it. Nothing else I want. Nothing else I want. I spent huge amount of my time, though I'm pretty busy with my projects in this company, in my Volvo company. Still I am spending huge amount of time to bring up a excellent content, so that many people who are aspiring to become DevOps and an ML ops or ML engineer can learn it interactively or intuitively. So that's the reason I'm doing it. Just support me in this. That's it. Okay, so with this, we will move on to the next stage. That's where we will use Jenkins, and we will automate all the processes. One click, all things should be done. That's what we are going to build in our next slide. Just be with me. So here in this slide, we are going to look into we are going to automate the complete DevOps process from development, continuous integration, continuous delivery, and deployment. All the processes from developer till ops, till exposing it to the external world. Everything, every inch of that complete process, we are going to automate it using a certain tool. So now, but before we start exploring this part, I would like to show you some of the conventions that I have used here. The blue one, the blue arrow with the dotted lines is our push, and then if it is a red, it's pull. You look at the bottom most of the screen, and then for manual step, yellow. So here we don't find a lot of manual steps, one or two. So automated step, it's absolutely red. And then for the feedback, auto feedback, you have written as a feedback inside that arrow mark. And if it is manual feedback, it's a dotted line and inserted with a feedback word. Okay. So that's these are the conventions of this pictorial representation of automatic DevOps process. Okay. So again, the process goes in the same way. All are same. Like first shelf consists of the processes that are running, and second shelf consists of an artifact server. So where all our artifacts will be published, and then the bottom shelf consists of the system admins and then quality assurance guys who do those tests and gives the feedback back to the developers. This is the system that we set up now to automate all the processes of DevOps ecosystem. What we need is a different thing. So we need another server. So for that, we will reach out to the system admin. So system admin has set up a server. He has provisioned a server. In that server, he has configured with some tools like Java Development Kit and then Jenkins. He has installed these tools inside that. Then that server will become a Jenkins automation server. So now we have a server to automate everything. Now we will start working on this. Now what we'll do is, the next step is, we have to write a Jenkins script. It's a Groovy script. We will write a Jenkins file using Groovy script. Whatever activities you want to do, you want to automate it, all activities, as soon as the code is been pushed to the code repository or SCM, from that moment rest all activities should be completely automated. So that's the thing we have to write in our Jenkins script, or we call it as a Jenkins file. Here in Jenkins file, cap J is capital. So you write the script, and then once you execute, all the processes will be automated. Okay, so now we will begin that. So anyway, as usual, the development process, that's a manual process. The developer will push the code into the code repository. Sorry, developer will pull the code into the code repository or SCM. Then developer 2 will pull that code back to his computer in the local machine. Then again he will push the code back, and then once the code is integrated completely into the code repository or SCM, that's it. That's it. Once the code has been pushed into the repository, now it is time to Jenkins to take over the complete setup. So the code has been pushed. Now Jenkins got the signal from there. Now the Jenkins will communicate with the build server where Maven is installed. Now it will do unit test, then it will do packaging of that. Once the packaging is done, then it will publish it back to the artifact registry. Everything is automated completely. You are not going to do anything. All is done through the Jenkins server using the specific servers. Once it is published to the artifact registry, now it is time for the setting up test environment. So anyway, the test environment will be set up by the system admin well before. So then the Jenkins communicate with the testing environment where we might have installed the Sonar Cube. Then that automatically the test environment will pull the artifact from the artifact registry, and then it will do respective tests. At the same time, user acceptance tests will also be taken care by the user acceptance test server. These are all things will be automated. We are not going to do anything other than setting up the servers and configuring the servers based on their need, whether it is test environment or staging environment. Okay, once it is done, then all tests that we have written, that test file that we have written, like dev test, regression test, performance, compatibility, everything will be completed. Once it is done, it will be promoted. The healthy artifact will be promoted to the registry. Then again we will have a staging environment. The staging environment will pull this artifact, and then there it's a production replica. So there all the post deployment tests will be done. Once that is done, then the application will move into the artifact repository again, the healthy one. Then this one finally move for the deployment. So here what will we do is, our production server will pull the healthy on completely tested, validated artifact into the production server, and then it will be deployed and it will be exposed to the external world. So the last one is deployment. So here we have seen development, which is manual, then continuous integration from code repository till test environment. This part is continuous integration, and doing unit tests and packaging it. It's nothing but a building. So this part is called continuous integration. Then after that, from test environment, staging environment, doing all the tests and completing the validation and testing. So that part is called continuous delivery. Continuous delivery. That means you're making your application ready for the deployment. It's a delivery. Then at the final stage, we will unpack the archive and then deploy it in the server automatically. That's called continuous deployment. That's called continuous deployments. Normally CI/CD, we say CI means continuous integration. From as soon as the code has been pushed into the repository, code repository or SCM, it should be automatically taken, and then unit test should be done, and then it should be packaged or built as an archive. This is called continuous integration. And after that, once packaged and archived and published into the artifact registry, then the next thing left is to uh, pulled by the testing environment and do all the tests, and then promote it to the artifact registry back again. And if there are any issues, again send the feedback back to the developers using Slack tool. Then doing the staging environment, then in the staging environment, testing all the things. So this part, after packaging, after building an application, after you getting an archive and doing tests and putting in staging environment and testing it and promoting it back to the artifact registry, from here till here, this part is called continuous delivery. This part is called continuous delivery. Once it is delivered healthy, then the next thing is to unpack it and put it into the production server with the required service. Then it will be exposed to the external world. This is called continuous deployment. It's called continuous deployment. From pushing the code into the code repository or SCM till it is exposed to the external world, all together we call it as a continuous integration, CI, continuous delivery, CD, and continuous deployment. So this is what happens. This is what we do. This is how our Jenkins tool is powerful. This is how it makes the complete whole system automated. And then from Jenkins you will get a feedback. If there are any issues, the Jenkins will push that feedback back to the developer using some tools, and the whole system can be monitored using Prometheus or some other tool. These are called monitoring tools. At the same time, our testing servers, user acceptance servers, all will send the feedback, the manual feedback through the quality assurance 1 and 2 back to the developers. This is how the whole system can be automated using Jenkins server or Jenkins tool or Jenkins application. So we have seen the detailed explanation of DevOps manual and DevOps automated. So now we will look into the each stage of DevOps and what type of tools that we use. What are all the tools that are available in the market? And we'll look into the each of that ahead. So we'll begin with, so in development phase, we'll begin with the IDEs. So these are basically development environments. These are development environments. Now, the most famous one, even I really like it, IntelliJ IDEA. IntelliJ IDEA. So this IDEA, IntelliJ IDEA is very helpful when you're writing AML scripts and all, and even for the Kubernetes. Of course, everybody has their plus points and negative points. Whereas in ops, I go with IntelliJ. Whereas during development, I go with the Visual Studio and Eclipse and PyCharm. So Atom, NetBeans, AWS Cloud9, CodeBlocks, Jupyter Notebook is one more. So these are all famous ones. These are all famous development environments where you can install plugins, and it helps a lot. So then we will move on to the other stuff. So once you develop your code, you have to push it to the version control systems or source code manager. So basically, of course, you will push this into the some GitHub. But before that, if you have to push this code or if you have to pull that code, to make these things possible, you need some source code manager or version control systems. The famous tool is Git. The famous tool is Git, and then Bitkeeper is the one which is enterprise level. Then we have a Subversion. This is the maybe 6 to 7 years back, it was very famous. And then GNU Arc, monotone, concurrent version system, CVS, this was also famous long back. And Visual Studio Team Foundation, this is also famous. And these are some of the tools that we use. Then you have written the code, you have developed the code, then you used a uh, Git version control system to push it, but you need some repository where all the developers can push or pull the code. So that's what we call it as a code repository. The most famous one and widely used everywhere is a GitHub. In addition to that, there are other types, basically SourceForge, Snipple, Snippetmania, Snipped, so PHP, Snips.js, Snips Code project. These are all other code repositories. So then what we have is static code analysis. Basically to do unit tests, we need to have some tool. So that's we call it as a static code analysis. The most famous tool, even I really like it and I widely use it because as a machine learning engineer, we require a tool for Python and also Java, JavaScript all together. So Sonar Cube is the one which is compatible with Python, PHP, Java, JavaScript, and so on. In addition to that, we use Visual Expert and Code Sonar, PMD, Deep Scan, PVS. So that's it about static code analysis. Then we will move on to the unit testing tools. These are specifically used for unit testing. Snowpark, this is for Python, widely used. Mocha is for JavaScript. Simple test is for PHP. Emma is for Java. And C and C++ and C++ and .NET, these tools are a little far away from my my reach because I don't use much. Basically, we work on Python, Java, these kind of tools only. So then we will move on to the build tools. So from code is developed, then pushed into the GitHub repository, then it's been tested, unit testing is being done. Then what left is building the artifact. Let's take as a Java example because ours is Healthicious app which is written based on JavaScript and Node.js, React.js, and MySQL database and other tools. So now we need some tools to build the artifact, to create an archive. So that tool widely we use is Maven for Java and Apache Maven for Java and Python and PyBuilder for Python. In addition to that, we have Gradle, Apache Ant. These are also very famous tools, and Scala oriented build tool SBT. Then all set. Now your artifact is ready. It's been tested for units, and what left ahead is uh, publishing this artifact that has been built using Apache Maven into a server. A server. That's what we call it as artifact registry or package manager server. For that, you have to configure that server with some install some package manager tool. So the most famous tool is Nexus that I used a lot during my projects day in and day out. So Nexus is the famous one. In addition to that, some enterprises will go with the IBM Urban Code Deploy also, but that's little costly. That's expensive. And in addition to that, if you use a Azure cloud, we have Azure artifacts and AWS artifact. Everybody has their own artifacts, but the most widely used tool is Nexus ProGet IBM Urban Code Deploy. That's called IBM UCD. Then Helix artifacts. So now our archive or artifact has been published into the artifact registry. Then what ahead is, now we will go for the full blown testing. That is, we will set up the test environment, and we have to install the following one of the following tools so that we can do the tests as written by the test cases. So Selenium is the famous one for the testing, whereas SonarQube is famous for the static code analysis, whereas full-blown unit test or full-blown component test, we use Selenium. This can be used in testing web applications, supports Java, Python, Ruby, Groovy script, and JavaScript. It supports most of the scripts that are available presently in the market. So that is the reason I prefer Selenium. We use Selenium also. APM is one more tool which is widely used for the Python. PyTest is specifically used for the ML applications. In addition to that, we have other tests, Sahi, API testing, and Postman. Postman is also used for the API testing. Then there are more tools in testing, that is Postman API and Gatlang, Gon, GonTLT, QUnit. It is famous for Java Query and Java Query user interface and Java Query mobile. Basically, in mobile applications, QUnit is famous. And then Cucumber and TestNG. These are the famous tools in testing in to install in a testing environment. Then, as I told you, so as the tests are going on, and it has to send back the feedbacks, and after testing is done, while the whole system is going on, you have to get the feedback. You have to monitor what is happening, and you have to monitor the whole automated ecosystem's performance. To all those things, you require a tool. Okay, that tool, what we call it as a monitoring and feedback tools. The most famous tool is Nagios. Nagios is the most famous tool that offers server application and network monitoring capabilities. That means, see, in our DevOps ecosystem, we will have plenty of servers. Plenty of servers. We will have testing environment, staging environment, and artifact registry, or Jenkins automation server, Maven server. Will have a lot of servers. So we should have a tool that can monitor server, that can monitor application, that can monitor networking, that can monitor uh, artifact registry, everything. So Nagios is the famous one. After that, the Prometheus. Prometheus, the benefit of Prometheus is it can also do monitoring for all the above things that we have mentioned. But in addition to that, the Prometheus comes up with a graphical display. It clearly displays everything, so it's visually appealing. So that's the reason these Nagios and Prometheus are the famous tools. In addition to that, we will have a Splunk, Elasticstack, ELK, Big Panda, App Dynamics, Cavo, Search, and Jabix. These are the other tools that we use it. Then what we have ahead is infrastructure as code. Now, till now, we have seen most of the things have been covered. We have reached to the development and then deployment, and then deployment stage. So now it's time to just look back. So the question that I ask you is, see, we are talking about the provisioning and configuring the servers for the various applications. But who does this? How can we do that? How can we automate that? Normally, a system admin, every time we request for a server, he will set up the server. That's what we call it as a provisioning the server. And after that, he will install the required tools in it, so that it's called as configuring the server. Once it is provisioned and configured, then we can use it successfully in our processes. But uh, can we automate it? Can we automate all these things? Yes, we can do it. That's what we call it as an infrastructure as a code. Ahead sessions, we will dive deep into this. What is infrastructure as a code, and what all scripts that we use, and what is imperative, and what is declarative script. All those things we are going to look in the coming fourth slides. So you don't go anywhere. Just follow the slides. That's it. And here in infrastructure as a code, IAC, we call it as IAAC. So IAC. So now we will first see scripting types. Bash is for Linux, Bash, and PowerShell is for Windows, and command prompt is also for Windows, and Debian based Linux terminals and RMP based Linux terminals are also there. Bash, sh, and kosh. These are all other types. These are part of shell types, but there are different types in Linux too. So these are all scripting types. Everyone will have their own scripting. And now, to provision the infrastructure, to create a server, we in spite of doing manually, we can do it using certain tools. The most famous tool in that is Terraform. It's a Terraform, the most famous tool. And in addition to that, we have Azure Resource Manager, and Google Cloud Deployment Manager, AWS Cloud Formation, and OpenStack Hit. These are all the tools which can be used to provision infrastructure automatically without a need to creating server and then installing and all those things. Without that, you can completely automate the provisioning of the infrastructure using IAC, using the tools that I have mentioned just now. Then we will look into the more functions of the IAC. So initially we have seen the shell scripts. Now we will see declarative type languages. There are different declarative type languages that are used basically in Terraform, Vagrant, Ansible, Azure, ARM template, PowerShell, DSC, Puppet, Chef. So these are all certain tools who where we can use a declarative language and then configure or provision the servers. And then we have templating the server configuration. That is Packer. That's the Packer. So Harcy Core Packer, and then Emulator or Vagrant. So here what happens, you write a script. We will do with the Vagrant anyway we are going to use. Even Packer also we are going to use in coming forward slides. And so Vagrant, you write a script, you just download the file from the internet, and if you execute that Vagrant, it automatically creates a virtual machine. That's the powerful. That's how you use a Vagrant to template the server configuration. Even you can add what all tools you want to install inside that server. It will automatically install. This is called the configuration. This is what we call it as a templating the server configuration. Now, configuring the infrastructure. To configure the infrastructure, we have plenty of tools. The famous tool is Ansible, and then Chef, Puppet, SaltStack, PowerShell DSC, CF Engine, Rack HD, Juju, Cobbler. Cobbler is also famous tool, but most widely used tools are Ansible, Chef, Puppet. Then we have container orchestration. Before that, we should have looked into the Docker. Okay, that's fine. So now there are few tools which makes containers, that is Docker and other kind of tools. But whereas we have container orchestration tools that actually make microservices concept possible. So Kubernetes is the famous one, and then Docker Compose for the low level, Docker Swarm is all low level, Minikube is for the testing, but production level Kubernetes cluster can be get from the Docker KubeADM and then COPS of AWS, whereas Minikube is only used for the testing purpose, just for exploring Kubernetes. That's it. And Marathon, Containership, and AZK, GKE, that's a Google Kubernetes, Azure Kubernetes Service, AKS, and Amazon Web Services, EKS, and Nomad. These are the famous tools which are used for the container orchestration. Then what we have ahead is the containerization. That's what I was saying. So the containerization. So there is a concept called inspired of deploying that application in a specific server or in a virtual machine or instance. What you can do is in that instance you can create a plenty of servers and then plenty of containers, and you can deploy your application using container also. For the container, the most famous tool is Docker, and after that we have OpenVZ, Hyper-V containers, LXD and Rocket, and Windows Server containers. This is specific to the Windows. However, the Docker is the most widely used tool, so we are also going to work with Docker only. We are going to spend huge amount of time in Docker because these days Docker is the most famous tool, and most of the recruiters are looking for the person who knows Docker. I'm specifically talking about the data scientists who should know Docker. Then we will move on to the automation tools. So now whatever activities we wanted to automate, whatever tasks that are there, we want to automate. If you want to make all these tasks automated, the only you need certain tools, the intermediary tools who can communicate with all the servers and all the tools and make this activity possible. So those tools are called automation tools. The most famous tool is Jenkins. Then after that, GitLab CI. GitLab CI is another famous tool. I saw most of my friends using this, but we are using Jenkins. Then Azure DevOps and Bamboo is another tool which is famous. Then Circle CI. This is also famous tool. Circle CA and AutoRabbit, and some use IBM Urban Code Deploy that has a capability for continuous integration, continuous delivery, and continuous deployment too. However, in this course, we are going to explore a lot about Jenkins. We are going to spend huge amount of time on Jenkins because these days most of the recruiters are looking for a data scientist who knows continuous integration and continuous delivery pipeline concept as well as containerization concept. So that is the reason I request most of the data scientists to follow this course religiously. Then we will move on to the web servers. So web servers, everyone will have their own purpose. Apache Tomcat server is widely used for hosting the Java application. Nginx can be used as a load balancer or web application server. And Flask is a Python framework server. JBoss, Microsoft IIS, Glassfish, and each have their own purpose, and each will help in hosting certain types of applications. So far we have seen a DevOps in detail, and now we will put all pieces together and try to understand everything in one from one infographic. So let's summarize all the details that we have learned so far in DevOps. So if you look into the leftmost portion of this slide, so there you'll find your project insights. So initially, you should know what all project insights such as project status, what all backlogs are in work in progress, and build status, dashboard, etc., etc. On other side, if you look into the rightmost portion of this infographic, you will find an artifact registry, a private artifact registry. So any private and you get npm maven packages can be kept here and be stored from artifacts feed while development and then build process taking place. So these are the primary requirements, making an artifact registry, and so that you can store the, you can publish the artifacts there. So these are the primary requirements. Now we will look into the overall flow of the DevOps from customer till production. So we will begin with the customer. So customer has come up with requirements. Now these requirements will be converted as backlog by the business analyst and then product owner. And once these were converted into the backlog, now it's time for engineering team to do the planning of sprint and capacity. After that, it will go to the test engineers. Then test engineers do the test planning. They'll start making the test planning. And once engineering team and then test engineering team both has planned for the sprint and then their capacity planning and test planning, now it is time for developers to pick backlog items or bugs from Kanban boards or work items and start development. So then the developer finishes off the code and send the code for pull request and collaborate with code reviewer. Upon completion of the pull request and code review, developer commits the code to the repos. That is our GitHub in our case, or it could be anything, that code repository. So there commit the code. Once it is committed, then our Jenkins comes into the picture and it picks up that code repo from there, and then the pipeline that is built will start acting. So now build gets triggered after every code commit in a repo. We will use Maven tool for health issues app because of JavaScript. Then once it is built on successful build and unit test run, build output gets deployed to the targeted environments. At this moment, our first targeted environment is testing. So it will move into the testing environment. In that testing environment, all testing cases that have been written will be executed. Once the tests are executed, then the test team will build. Once the build is deployed, then the tester starts testing and logs defects if any in Kanban boards or work items. Then once that is done, then if testers are satisfied with the build, then build gets promoted to the upper environment. What's the upper environment? The next upper environment for us is staging. Then basically all these artifacts after testing, it will get back to the artifact repository and it will directly bring into the staging environment. Now the artifact is entered into the staging environment. So in staging environment, we will do some tests, but the most important tests related to the business users. The first one is business user starts testing at UAT, that is user acceptance test environment, and in pre-production. And then any defects observations gets logged in Kanban boards or work items. Upon user satisfaction, build gets promoted for the production environment. That is the ultimate environment, because after that we can expose that application to the external users. So now the application has been pushed into the production environment. Once it is pushed into the production environment, it's time for the external users to access it and enjoy the fruits of that application. So with this, we have covered the most of the DevOps, and I tried to give you the intuitive understanding behind that. For that, I spent huge amount of my resources, time, and tools and many other aspects. I would like you to request, enjoy the video and you watch it and you spread a word to your friends so that everybody can get a huge amount of benefit out of it. All the best to everybody. Keep enjoying my videos and keep watching my videos. Just follow me and subscribe my videos. Thank you and see you again on another module of I DevOps for you.